Hi, Assalamualaikum. My name is Nur Kamarina Shazwani binti Kamarosli. My metric number is 194251 and I'm from Aerospace Engineering Department.
Okay. My name is Siti Nur Sabiha binti Muhammad Saleh and my metric number is 192546. I from Computer and Communication System Engineering Department.
Hi everyone, my name is Ghassan. My metric number is 195569. I'm from Faculty of Engineering, studying mechanical.
So before we proceed with our discussion, I would like to tell everyone that we choose topic integration for our video assignment. So I would like to introduce what is integration. Integration is often introduced as the reverse process of differentiation and has wide application. For example, finding areas under curve and volume of solid.
Okay, so guys, I have surprise for you. Okay, let us play game.
Yay.
I have this number. Each person have to pick one. Yeah,
Okay.
have to pick one, and I have prepared a question for you.
Okay.
Yeah. Okay. So, how lucky tangan you? No.
Oh, I'm number 4.
Number
I
four.
number 1.
I got number 2. Okay.
Okay.
Okay. So this one is your question. Who got number 1?
Me.
Okay, number 2 is me and number 4 is you.
Yeah.
So you can read the question
I think
and
we need to exchange the question.
what?
Who's number 1?
Okay, it's fine. Okay, read your question and you can do your question, solve your question first before we explain.
So I put this equation and I integrate it becoming in velocity in term of t. So I get this equation, but I got c, and the next paragraph it state that from a position at rest in a silo 35 meter below the ground level. So I think that at rest, so x equal to 0, v equal to 0, and I assume that t equal to 0. But it state that in a silo 35 meter below the ground, so x is equal to negative 35 and velocity is still the same, v equal to 0, and t I assume that equal to 0. So I will got the c equal to 0. Next I will integrate it to find the x. So I got x in term of t, 2/3 t cube plus c, and I assume that when the question given that the x is negative 35 when t is 0, so I found that c is equal to negative 35. So the question is actually want to know how high above the ground will it be after 6 seconds. So instead that above, the x answer will in a positive, and in term of t equal to 6. So after I got x in term of t, 2/3 t cube minus 35, I put the t equal to 6, and finally I got that when t equal to 6, the position is at 109 meter.
Okay. Now we responded like this. So I'm gonna start from the first. From the equation f of x equal to kx. Now this is a function, okay guys? This is a function. So what does the K means? It's the spring constant, which means the limitation of spring. Okay, so the question wants us to find the work. Okay, then he gave us in the question he gave us the force, and it's 25 Newton. Okay, and 1/4 is the stretch length only, this one. Okay, and what else? Okay, 1/5 is the stretch length only. Okay, as we always know, x equals to distance. So the length of spring stretching is the distance between of spring. Okay, so now let's solve it. F of x equals to kx. Okay, the force 25 Newton, it will be here, equals to k, the constant, 1/5 meter. Okay, then we have to remove this 4 from the k. Okay, so we have to do it like this. 4 into both sides, one here, one here. Okay, so this one is gonna be go, and this one is gonna be go. Okay, it will be on this one 4 into 25. It will be 100 Newton. K is the constant and m is the meters, equals to 100 Newton. Okay, we have to decline this one and keep it alone for the constant. Okay, so we are gonna divide the meter over the constant and over the force. So it's gonna be like this: 100 Newton over meter. Okay, so now we have the number f of x equals to 100 x. Now we have to integrate it, as in this, to determine how much work. Okay, so from the integration, as you know, 1 plus 1 over 1 plus 1, so it will be 100x squared over 2. It will be 50x squared. So now we will do the integration. 2 and here 0, because they gave us from the question, and you are gonna put the 2 ones here and the 0 ones here. So 50 into 2 square is 200, and 50 into 0 square is 0. So 200 minus 0 is 200 joule.
Okay, from the question, we know that this curve is resolved about the x-axis, mean the resolvation occur in x-axis. So we know that x-axis is 1 and 4, x0 is 1 and x is 4. So they already give the area under the curve and also the y fx. Okay, if we want to find the volume, we have to differentiate the area under the curve. So we can substitute pi r square, and since the pi is constant, so we can put outside the integration. So r square is actually the radius is actually the y axis. So we can put the function, we can substitute. Okay, then we substitute the x square minus 4x plus 5 bracket square dx. Then we have to expand this first. So when we expand, we got to the power of 4 minus 8x to the power of 3 plus 26x to the power of 2 minus 40x plus 25 dx. So we have to integrate this equation. We will get this equation, and since we already have the value of x0 and x, so we have to put at the back 1 and 4, and we have to substitute this value into x value, each one for both 4 and 1 value, and the final answer we get 78 over 5 pi.
Okay guys, this is the fourth question. We are gonna do it together. Okay? Okay.
Okay.
What is the first step?
Yeah.
How to do this? How to integrate this question? From
2. You have to put 2 and 0.
2 and 0.
Yes.
I think that we need to use the
Yeah.
integration
Yeah.
identity. So
Oh, this one.
the number this.
Oh yeah, number 4.
Yes.
Okay, I got it.
Okay.
So this is the solving that we got after we discuss the question.
Okay guys, this is all what we have for today. Thank you, and if you need anything you can ask us.
Okay,
Bye.
bye-bye.